All right. The steps for solving are pretty straightforward. We're going to practice a lot. If you've checked your calendar, we're going to do this for like 3 days. So don't anybody panic. Step 1, just like way back when we were doing absolute value, is we need to isolate the radical, so the square root, on its own side with everything onto the other side. So we want this square root of 4x plus 8 all alone. So we're going to add the 4 to root 4x plus 8 equals 12. Divide the 2. Square root of 4x plus 8 equals 6. Okay? So far, so good. Now, the opposite or the inverse of square root is squaring, but we've been working with stuff that has all kinds of different index values. And so when we look at step 2, it talks about raising it to a power equal to the index of the radical. So that's where we remember there's a 2 here, and so I'm squaring it to clear the radical. So I square the other side also. If this was a cube root with a 3, we would cube it, raise it to the 3rd power. If it was a 6th root, we would raise it to the 6th power. But this one's a 2, so we're simply squaring. So that leaves 4x plus 8 equal to 36. Okay? Nothing crazy here. Then we just solve. Subtract 8. 4x equals 28 divided by 4. X equals 7. I can't stop here. It looks perfectly good. We did all of these steps correctly. But we got this 7 after we squared this value right here. Okay? So I have to go back and make sure that in the original conditions of taking a square root, that 7 is still a valid choice. So we're going to go back to the square root of 4x plus 8. The square root of 4 times 7 plus 8. And the square root, 4 times 7 is 28, plus 8, square root of 36. I can take the square root of 36. It's 6. It's something I can work with. Key here is that it's a positive number that is a valid, that gives me something I can work with. It's not imaginary. Okay, so we're okay. You can go back and say, yep, x equals 7 is legit. Now, example number 2, if you're using this handout, this is a typo, and that should be extended all the way across. That's my fault. Okay? That does not mean anytime you see something that's outside, you should go ahead and extend it. I am just saying right now, this is a typo. Fix it. Make it look like this. Okay? Now, I can't isolate this because there's 2. There's no way to get it by itself. But what's nice is that this is a square root, and this is a square root, and that's all we have to work with is 2 square roots. So we're going to go straight to the part where we raise it to the power of the index. They're both square roots, so they both get squared. This would not be an option if one was a cube root and one was a 4th root, right? If they're not the same index, then I can't use this approach. When we do that, I'm left with 3x plus 1 equal to 5x minus 1. Just solve. So take 3x. 1 equals 2x minus 1. 2 equals 2x. Divide by 2. X equals 1. When I go back and check it, 3 times 1 plus 1 is positive. 5 times 1 minus 1 is positive. We're okay to go. Okay. How does it change when we've got an inequality? Well, it doesn't. Okay? It really, really doesn't. Still need to isolate. Okay? 5. So negative square root of 20x plus 4 greater than or equal to negative 8. Divide by negative 1. So the square root of 20x plus 4 is greater than or equal to negative 1. Okay? When we get ready to solve this, okay, we want to consider the graph. So if we think about our graph, okay, I want to know where this equals 0 so I know where this thing starts. So 20x plus 4 equals 0. 20x equals negative 4 divided by 20. So x equals negative 1/5. Sorry. So if I mark negative 1/5 here, my square root curve we know looks like this. And I want to know when it's greater than negative 1. Well, negative 1 is down here. So this function is always greater than negative 1. All real numbers is the temptation. But we're looking for x values. So we want to come back in and say, okay, it's all of the function, right? All real numbers means everything, but this very definitely stops and starts at negative 1/5. So we're going to rephrase that to all real numbers greater than or equal to negative 1/5.